Okay. I have two my homework. The first one is the reference ladder. Reference is to regulate the rewrite with the 4-bit precision. And the circuit on the right is to describe the design methodology. And then I train a V reference from the 0 to 3 to train the VR. And then I make a schematic and a symbol from this image. Then after create a schematic and symbol, I have some case like just say one is a reference, 1, 2, 3 is a 5 voltage, and I get the Vref is a 2.2 and the V later out is a more approximately 800. And another case is a Cascade 2. The related out is a 1.8, approximately 1.8 voltage. And then with
wait. So in test K1 is wrong or right?
no, as I said it before, it true because when the rewrite is 2.2, with the various reference from 1 to 3 is 5 voltage, and then this will be not close. So we can calculate the VR from the ladder is the 1.1 voltage.
So in case 1 is wrong, right? In test 1.
I think that's when I apply the 5 voltage, is the MOSFET is not open, so the VR is from the rewrite divide with 100 and multiply with 36. Is that right?
Yeah, but we always want to control V ladder out to be 1.8 volt, right?
Sorry.
You look at source page.
Okay.
Okay, no. Okay, I will share my screen later. Let's continue.
Okay. The 2 is the level shifter, and then I put the inputs. It will change the voltage from the V star to the V high. But I has a schematic and a symbol like this. And I have to test the input with a clock like this with the amplitude with the 1.8, and the output have the same shape, but its voltage is the 5 voltage. It does change the voltage, but not change the shape. And the 3, the pulse with control. I have my schematic from the input. We have the PD and the NT with the delay. Like the TD is equal to 90. TP is 9 TD, and the TN we can change the delay by we change the we reference from 3 to 1. We can change the precision of the delay. And then I have the first one. I make a delay block from the Korean book like this, and I test that the delay the 26 picos and then second. And then to have the TD is a 7, 8. I make the series delay block from this block, and then I have the symbol. The TD block is with delay 78. I have a test like this. And then I make the schematic for the pulse width control with the delay block. I have did it. And then I make the symbol. But when I test the output is not the I don't understand the output.
We wrap out.
Yes. I don't know exactly the sorry. I don't know exactly the input. Input up here. It has is from the arbiter, but I don't know the shape of its signal.
Okay. Let's
Okay.
continue.
Okay. And then I after make symbol like a reference letter in the comparator, and this is the full generator, and this level converter. I make whole system, but it's miss a bit of block. So because I don't know exactly the miss a bit of block, so I don't know the acknowledge bug signal as well the reaction bug signal to create the miss a bit of block. Yeah, this is my presentation. Thank you so much.
Let me share screen.
Okay.
Will you see my screen?
Yes.
So in here you put 555, right?
Yes.
So this switch will be open, right?
Okay.
5 volt. Here PMOS, so 5 volt mean the PMOS will open, right?
Okay.
So here will be 32 mega ohm, 16, 8, 4, but on 4 switch is open, so VR will equal it will be equal Vref VR will equal Vref multiply. Here is 36 mega, right?
Yes.
36 mega over 36 plus 4 plus 4 plus
It's the
8
100.
plus 16 plus 32.
Yes.
So
The
it will
total
be
is 1.36. Multiply with 2.2.
so
And then
VR will be nearly 800 millivolt.
yes, because I put the direct in the 2.2.
So we 2.2.
Yes.
Okay, 0. Whoa. Whoa. But actually we want to control VR to be 1.8 volt, right?
Yes.
Because your comparator will compare this VR with 1.8 volt, right?
Yes.
But VRAC will change from 2 to 5 volt, right? 2 to 5 volt. Here is also 2 to 5 volt, right?
Okay.
So, for example, in here, we buck converter will change from 2 volt to 1.8 volt, right?
Okay.
So this divider will make Vout equal to nearly 1.8 volt. Okay.
Okay.
Then in your converter, V store is fixed 1.8 volt. Okay.
Okay.
But VRAC will change like this. So it can be changed by controlling reference voltage, right? So VRAC can change from 2 volt to 5 volt, depend on the reference voltage. Okay.
Okay.
So for example, V store is always 1.8 volt. We are controlling V rec to be 5 volt here. And then we want to control to 2 volt. So we will change reference voltage and then the control signal from here. Actually, it will come to control block to change the power width of P mode and N modes, right?
Okay.
So then we can control redirect to 2 volt. So Vout here is always nearly 1.8 volt to compare to this. Do you got it?
Yes.
V here is always 1.8 volt, and VRAC here is changed from 2 to 5 volt. And reference signal bit here is 4 bit, right? Did you read it carefully? It's 4 bit control to control VRAC. Okay.
Okay, I do it.
So VRAC 4 bit. VREF 0, 1, 2, 3, 4 is 4 bit, will control reference voltage. Do you know N? What is N? Do you know what is N here?
Yes, when we change the N from the 1 to 50, we could change like from the 2 to 5 volts.
How we can change N?
Oh, I don't know.
And actually we can change N. N mean 4 bit, right?
Okay, okay.
We have VREF VREF 0, 1, 2, 3. It is 4 bit, right? This 1 bit, 2 bit, 3 bit, 4, right?
Okay.
VREF 5 volt. 5 volt mean 5 volt. See that bit is in here. 5 volt here is 2.2. So here you have VREF is 2.2, right?
Yes.
2.2. Here 2.2 mean n is 1, right? N is 1.
Okay.
So we have n is 1. VREF VREF 0 volt 0 volt. This one we have 1, we have 2, 3, we have 3, 5 volt. So in bit 0 volt mean mean 0, right? In
Bro, I have understand it's wrong.
do you understand it?
Yes.
So it's 0. And it's 1, right?
Okay.
N is equal no, it's I think this might be wrong. It should be it should be -1. So here is bit, right?
Yes.
So now is n is 1, and then if we change reference 0 to 5 or other things, so this 4 bit will make n change from 1 to 15, right? You know it, right?
Okay.
To be in here, four bit will change the reference voltage, but Vout is always 1.84, isn't it?
Yes.
So for example, in here 5 volt. So in here n should be 15, right? 15. So 15 and 15 and that will be 5 volt, isn't it?
Yes. Bro, I have a question.
Yes.
Yes, we know the direct and we train the reference 1, 2, 3, but the chip, why, how it can know the direct to train the reference?
So VREC is we manual change it. So VREC is just V1. So in here, in here,
We know direct before and we change the reference follow to it. Yes.
you know you buy a flip rectifier, right?
Yes.
Actually, our own system is here. VREC here. You learn about bias flip rectifier, right?
Yes.
In bias flip rectifier, we have maximum voltage when we rack here. So we want to have the maximum voltage, right?
Yes.
So depend on the input IP. So if we change IP, so we know how much is VREC to be the maximum power. So VREC, we choose VREC depends on the input in here, in the piezo harvester.
Okay, I got it.
You got it?
Okay, wait.
So we choose it. So we choose VREC based on the input of piezo. So here 5 volt, N will be 15, right?
Yes.
15 mean on VREF here is should be 1. On is 1, right?
Okay.
1, so this would be -1. -1 equal 15, right? Okay.
Okay.
15, so it's 1. So this switch will be turned on, right? Turn on and it will be short this. Short this one, short this one, and short this one, short this one. And on this register will be shorted, right?
Okay.
So now Vout will be equal VREC 5 volt multiply 60 mega over 60 mega plus 4, right? Now it's only 4 mega ohm left. Only shorted, right?
I think it's the inverse because when V is a 15, the VL is more than 1.8. I think when
so now 5 14 plus 16 plus 5 oh I was wrong. So
I think that's when we inverse, like when the 15 we change the 1 to 0 and 1 to 0. Instead of maybe two.
Yeah, it should be opposite, right?
Yes, yes.
Should be opposite. So it should be 5/16. In here, total is 100.
Yes, yes.
8. Right. 100. So right. This will be 1.81. Do you understand what I mean?
Yes.
So we change the bit to change VREF, but VOut is always 1.84. Okay?
Okay.
This 1.8. 1.8 because we compare with 1.8. Okay?
Okay.
So then this letter with the will make okay, and this so how much is this? So clock here.
Bro, because I don't know the acknowledge signal, so I just have random clock to test the output, but I think it's not true.
Clock
Yeah, I test random.
input. Clock mean input, right?
Yes, I test it with clock.
Yes, so because it is 9 PD.
Yes. I make the delay block with the TD. Like I can is the TD with the 778. And
So
the
here is
GP is
9 TD, right?
yes,
TD here is equal to 9 TD, right?
yes.
So in
I
here,
calculate TD is the 78.
1 TD is 78.
Yeah.
So 9 TD will be how much?
More than 700. Let me check it.
700.
702.
So from here, raising at the clock, and then it will delay to here, right? PD.
Yes.
It will be 7 from here to here, right? Will be 9 TD, right? It will be 9 TD.
Okay.
In here is 9 TD. Okay? It is a delay you make for PD. And here, how much reference with your reference with bit you change? So
I
you make
just
0 bit, 0. You make all 0.
no, I make the 5. I want to
5.
yeah.
So here only 1 TD.
Yes.
1 TD.
Okay, let me check again.
It is here 1 TD. It will be here to here.
Let me check. I don't do not remember.
Why strain?
I put the 5 voltage. The TP is should be 700 and 2, and the TN should be 157.
Andy,
Sorry,
you
TN,
mean Andy, right? TN, right?
yes, TN is 157.
100, but in here only 78.
I think it's wrong.
If you set on is 5 volt in reference, so delay only 1 TD, right?
Yeah,
In here, TN will be 1 plus N TD. So you set on reference to 5 volt mean N is equal to 0, right?
yes.
But why your delay is
But bro, I don't understand the input of full width control. The input. What is the input of this block?
input will be from comparator.
As my comparator, when I compare it the red book signal either only one high voltage or or low voltage. That's right.
So output of comparator will be low or high, right? Right?
Please open the block for comparator. I have a question.
Yeah.
Okay. Yes. Bro, I have a question that it is when I compare the VP and the VN. So I get the output is output P and output N. For example, when I VP is the more than VN, the output P will be high and
So
output
in
N will be
here,
low.
you're taking plus. So your output should be plus output P.
Oh,
Okay. So you connect
okay.
with output P and then connect to your power control.
But my problem is that the ramp up may mean the output of P is always higher voltage. It's not something like
Hmm?
it's just high voltage. The output
What?
P, my output P is always higher voltage. It's not have a shape like clock that you draw.
Because your overall system do not work well.
Yes.
So I will make one full system for only one example. I will make one full system example with VRAC 2 volt. Okay, only
Okay.
one VRAC, and you have to change the bit to control reference, to control VRAC. Because now I think quite difficult for you to make your full system by your own. So I will make one example and then I will send you later. Okay.
Okay. Okay.
Ryan, can you share your screen?
Yes. By the way, like there's only like 4 minutes left, so should we like rejoin first?
Yeah, okay. So make new link.
Okay, let me share my screen now. So
Yeah.
enable screen sharing.
Okay, I admit. You can share your screen.
Okay. Um, so, okay, can you share a screen right?
Yes.
Yes.
All right. So in this presentation, I made the schematic of these three things: reference ladder, pulse width control, and inverter circuit, and simulated. So first, the reference ladder. So reference ladder works like this. So there is this direct, which is 2 plus 0.2 n, where n can be from 0 to 15, and we have to bring down the Vrect to V out, which is 1.8 volts. So regulate Vrect to 1.8 volts. So this is my schematic design. I've also included the schematic from the book just for the reference. So here are these two. And these are the parameters that I use for the simulation. So my output is V out, and these are Vref and Vref. And if we see the output plot right here, V out, as we can see that the V out is actually pretty close to 1.8 volts, 1.7999. So,
But in here, you only make for only one case.
yes.
You should change Vref to many bits, right? In here, you make on is 1 volt. Do you use
So
2 volt FET? So you use 2 volt MOSFET. So it will be similar to 5 volt in 5 volt MOSFET. So it's 1 volt mean on the bit is 0, right?
okay.
It will turn on the switch, and so in your simulation you only make one case for Vref and 2 volt, and
Okay.
all the
So
bit
I should
is
so like
the
the VREF should be different, like the other VREF.
yes. Did you see Thai make it?
Oh yeah, I saw, yeah.
So it should be
Okay.
Vref 0, Vref 1, Vref 2, Vref 3. So you change
Mhm.
the V bit by control the voltage of Vref. So let's ask Thai later. So
Okay.
he understood it. So yeah, okay.
Okay. So this case V out was actually pretty close to 1.8 volts, as we can see in the graph.
Yeah.
And after, so then it's a pulse width control. So for the delay circuit, I used like from the SGT5 poles, this library, I used this Dell 2 cell.
Actually,
So,
I told you to use 2 volt library. I send you 2 volt library. Isn't it, Thai? Do you use 2 volt library?
I just make the delay symbol by myself, but don't do anything.
But for NOT gate and AND gate,
Yes, I have to the two voltage.
yeah, you should use 2 volt. In your logic cell 2 volt, do you see library?
Yes, I received it.
Ryan, did
in
you
logic
read?
cell 2 volt?
Yes, it is for 2 volt MOSFET. You did not read
Oh,
your
I see.
email carefully?
Actually, I already made this when you send that mail.
It has some
Actually, we work with 5 volt because 2 volt is just over the. It can make the 5 volt voltage to become change the logic, but
I see.
if your VDD is only 1 volt, so you cannot turn on the 5 volt MOSFET, I think, because you know threshold voltage, right?
Yeah.
To turn on, turn off a MOSFET, so you have threshold voltage.
Mm-hmm.
Because in here your VDD 2 volt and threshold voltage of 5 volt MOSFET is lower than 5 volt. So in here you use 5 volt library, but you still work well. However, the power, the delay might be different,
I
and
see.
yeah, other things. So
Mhm.
let's change to 2 volt
So
library.
logic cell, yeah. So I will change it in the next
Okay.
week. So logic cell tools, okay. So for now, what I made is that like I used that cell to make this schematic. So here's the schematic from the book, and here's thesis, and here's the schematic that I made. And these are the parameters that I use for the simulation, and here's the result that I got.
You should
So
zoom in, but in here I don't see a delay, right?
yeah,
You should zoom in, right? Zoom in to see the delay.
I mean it's a picture, so I cannot really zoom in.
Huh? You don't know how to zoom in the waveform?
It's a picture. It's the like screenshot of the.
Yeah.
Uh,
But next time you should. In here, in this picture, we don't know how much delay, right?
mhm.
So
Oh, I should have
your
included that.
your plot in here is meaningless, isn't it?
I see. I mean, we
Yeah.
can actually figure out.
You in here you don't know. I cannot see how much delay your circuit.
I see. Okay, I will keep that in mind the next time.
I think you might
So
ask. I see you have not fully understand the delay circuit. So let us try for it. He understood it.
okay,
So okay.
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 Next.
So and I also made one with CLK equal to 2 nanoseconds, which turned out to be a graph like this. And then and after that it's the inverter circuit. So the inverter circuit schematic actually look like this. So the here the low voltage is V star, the high voltage is V rect. So and the V out is right here. So the parameters that we use for the circuit are the following ones. And this is the V out that I got from the simulation.
So your VL is also wrong, right?
Yeah.
So I already make a good circuit, so ask him for help.
Okay.
Okay. So I
Just
only think you guys what you don't, what two of you cannot understand. So in which part one of you understand, so let's take each other to save my time, right?
okay.
I also have a lot of work to do. So
I see, understood.
yeah.
Okay.
Okay.
Tomorrow I will.
So
I will. Yes.
you
Bye.
guys might make meeting together to help each other in which part you understand
Yeah,
today.
actually we can do that, yes.
Okay.
Yes. We take a
Okay.
lot,
So
but
I
not have a meeting. Tomorrow I will.
Yeah.
Right. Okay.
so
Actually we will like work in the weekdays anyway, so
Okay.
yeah. Okay.
tomorrow and
I will be busy until next Tuesday, so I will send the full system schematic maybe in next Tuesday.
okay.
Okay.
Okay. Let's try to make your full schematic by yourself first.
Mhm.
Okay.
Okay. Okay.
Okay.
Read the thesis carefully. I see you guys have not understand the thesis carefully, so read sentence by sentence until you understand all your
whole.
sentence. He don't. Okay.
I see.
Okay.
All right.
Okay. See you next time.
Okay.
Okay.
See you.
Thank you so much. Good night, bro.
Yeah. Give me a recording.
Okay.
Bye.
Bye.
Goodbye.